Hey everyone, welcome to this lesson in trigonometry in context. So with everything we've been doing in trigonometry thus far, we've always been looking at just some plain old triangles that happen to be there, and we're just finding whatever angles and sides are in there. But these triangles can exist in real life, and that provides us a context where we can use trigonometry. There's a whole bunch of areas where trigonometry is used in real life. How much you personally end up using it in real life is going to depend on what you eventually go into. So it might be that you use it a decent amount. It might be that you don't use it at all, but that's going to come down to your own decisions later down the road. Whenever we are solving contextual problems, drawing a diagram can be super handy because if we draw a diagram, really picking apart the information that's given to us, excuse me, we can find possibly a right triangle. And if we can find a right triangle, then it becomes just like any of the other questions we did in any of the previous lessons, which is pretty wicked awesome. When we're drawing the diagram, we might encounter the words angle of elevation or angle of depression. And those angles are always drawn relative to a horizontal line. So if this is someone looking out, that's a long torso. And that's their line of sight that way. Well, that's a direct horizontal line. Looking upward would be an angle of elevation. But looking downward would be an angle of depression. But it's always relative to a horizontal line. Might be a handy thing to put on a resource sheet too. Angle of elevation, we elevate something, we go up. And then if something is, depressed, that means it's going like in a downward direction. So that's how we can recognize those terms. Well, let's get into it. Standing 179.8 meters away from CN Tower in Toronto, you look at an angle of elevation of 72 degrees to view the top of the tower's antenna. How tall is the CN Tower to the nearest tenth of a meter? So diagram can be super handy. If you don't know what the CN Tower looks like, bam, there's the CN Tower. Super handy diagram, and you can draw yourself there, and you're looking up at it if you want. If you want to get more into detail, then you totally can. CN Tower, what do you think? Kind of goes like this-ish. And then I think there's like there's a little building part. There might be a top part, I don't know. And then a little antenna on top. I think that's a pretty decent CN Tower. And then here we are, way at the bottom. Ta-da! We can draw the ground in there if we want. Looks like I'm floating. Better adjust that. I'm not a wizard. And we're standing 179.8 meters away. We're looking at an angle to view the top of the tower's antenna. So from here, I need to view the very tipply top up there. So I can draw a line for that line of sight. And I'm starting to see like, hey, I can actually see a triangle in here. I can outline that whole thing in pink. And I can fill in stuff I know. I'm standing 179.8 meters away. There's an angle of elevation of 72 degrees. And is that going to go up here or is it going to go down here? And how can we tell? There's a couple context clues you can use. One of them is that it's from our perspective, right? You're looking at an angle of elevation of 72 degrees. you're over here. So that's why this angle would go in that area. But the other clue is that it's an angle of elevation. And so angle of elevation being relative to a horizontal line has to be in this. If we drew it in here, it would be between the hypotenuse and a vertical line, which is a huge no-no. So that 72 degrees does have to be there. We're trying to find the height of the CN tower. So we could label that here. You want to call it anything you want. You want to call it H for height, you can do so. But we've often been using X, so we can just use an X there. And now, this is just like the stuff from the previous lesson. We can label our sides, opposite, adjacent, hypotenuse. We can select an appropriate trig ratio. Tan theta is opposite over adjacent. Fill in what we know. Tan of 72 degrees is x over 179.8. And as we may recall from the last lesson, we're going to take the 179.8, we're going to take the tan 72, and because x is on top, we're going to put multiplication between them and get an answer. So punch this into your calculator. Oops, see what you get. Make sure it's same as whatever I get. Nearest tenth of a meter, I'm getting 553.4. And then one just other thing, because this is a question in context, we have to give an answer in context. So we just need a full sentence this. The CN tower is about 553.4 meters tall. Boom, done. Alrighty. There are some examples on the next page. I think 3 of them. Yep, definitely 3. So give them a try. Draw the diagram. Spend a solid 50 minutes here. Just pause, try them out, and see what you get for answers. You can leave some room for your work versus actual work just to see differences if there are differences. Because again, very handy to have that record as to what you were thinking at a particular time. And then after you've spent those 15 minutes giving these questions all a very good, honest effort, resume the video and see what you get. See how it stacks up against my stuff. All right. 20-foot ladder is resting against a wall. Here's my nice brick wall. I'm going to have a ladder resting up against it. My ladder is gray. And my lawn, it's not covered in snow. It's nice and grassy. Does your diagram have to be this detailed? Heavens no. That's ridiculous. Also, you might not have this many colors with you. That's okay. Does the wall have to be brick? No. It could be vinyl siding. It could be stucco. I don't know. Follow your heart. It doesn't even have to have any details. But we do need to have this general vibe of, hey, there's a triangle there. For this triangle, the length of the ladder itself, oops, let me switch to my blue, is 20 feet. And the ladder is at an angle of 60 degrees to the ground. So it's not this angle we're drawing, that's the angle between the ladder and the wall. Here's the ladder, here's the ground, so we're going to fill in our angle right there. With that all done, we've got enough info to find, what are we trying to find here? How high up the wall it should reach, so we can call that X again. And we're just going to solve stuff in this triangle. I've got a hypotenuse, I've got an opposite, I've got an adjacent. So I'm going to choose the sine ratio. into this. To the nearest whole foot. So to the nearest whole foot. I'm not writing 17.3. That's not a whole foot. I'm just writing 17. And providing a contextual answer. And that's that one done. Next one. Ryan is looking out his office window. I guess he's got a brick office. And here comes Justin along the path. They are both blue. So there's Ryan in his window. Yay. And there's Justin walking along the path. Nice. That's a great building. That's a great path. Wow. This is the most beautiful drawing I've ever made in my life. There's the line of sight from Ryan to Justin. And there's a triangle in there. And there's a couple ways we can play with this one. We know his office window is 43 meters high. And we need to find out how far Justin is from the building. So like this distance right here, that's our X. But this 37 degrees, where does this go? We've got options. And there's a couple ways we can play with this. One is to note, hey, it's an angle of depression. It has to be relative to a horizontal line. Here's a horizontal line. So that's why this angle is going to go right in here. The other way we could look at it is with respect to Ryan, right? Ryan's the one who's looking out at an angle of depression. Ryan's horizontal line of sight is over here. And then this would be him looking down. But where's the triangle? Well, we could draw a vertical line that connects Ryan's straight out line of sight to the height right above Justin. And it turns out we get almost the exact same thing. There's a 43 on this side because this whole thing forms a rectangle. That rectangle split in half gives us a couple right triangles that are the same triangle with different orientation. One where I label it down here. And go from that point. Let's see, I've got an opposite and adjacent. I don't know the hypotenuse, so I'm playing with tan. Tan of 37 degrees is 43 over x. And as we recall from previous lesson, since x is in the denominator, between the 43 and the tan 37, there must be a division sign. Calculator says, oops, I did multiplication. Divided by tan of 37. To the nearest whole meter, I'm getting 57. So Justin is 57 meters from the building. And then the last one is about Tim. Tim is a pilot. Legitimately, Tim, I mean, it's not what his career is, but he can fly a plane. He has his pilot's license. It's pretty dope. Tim does a lot of things. Tim's also a sailor, like he does sailing and badminton. I know him through badminton primarily. Yeah. And a great math guy. He loves math. His wife also loves math. Everyone at their wedding loved math. It was nuts. There were very few people who were not math people at that wedding. Anyways, Tim's a pilot. Takes off at a speed at 4 kilometers per minute. After 5 minutes The plane is 3.47 kilometers above the ground. What average angle of elevation did the plane travel over those 5 minutes to the nearest degree? Neat. Well, we can start drawing this. A plane, eh? I can draw a plane. We'll have like the body of the plane. Some winglings on the plane. I'm gonna have to get an eraser up in this business. Can you have a window for the pilot if you want? Wow, beautiful plane. Or if you want, you can draw a plane like this and no one's gonna care. But however you draw it is drawn. Goes through the air, makes some ground distance, get some height. After 5 minutes, the plane is 3.47 kilometers above the ground, so that goes there. We need its average angle of elevation here. And we're going to need another side length for it. How are we going to find that? Ooh, Tim takes off at a speed of 4 kilometers per minute, and he's been traveling for 5 minutes. So how far did Tim go? Well, 4 kilometers per minute times 5 minutes is 20. So we know that his distance that he's traveled, how far has he gone, is 20. And doing it there, because that's the actual path he's traveling along. This is not the path he's traveling along. So ground distance versus air distance is kind of a technical point, but worth making. All right, coming in on this, I've got opposite and hypotenuse. I don't have adjacent. So I'm going to set things up with the sine ratio. And the opposite is 3.47. The hypotenuse is 20. So theta, it's been a while since we found angles, but we do the opposite sine of this 3.47 over 20. Let's see what I get. Sine inverse. To the nearest degree, I'm getting 10. Contextual situation, so contextual answer. And that is that. There is practice work, of course, for you to try. So try out that practice work. In the practice work, just make sure you go to 1 decimal place unless you're asked for something else. But our standard is going to be 1 decimal place unless otherwise indicated. And that is it. Is that the whole unit? Wow. That is the unit done. So keep in mind, there might be a test coming. And that's about that. Take care. I'll see you in the future.